Hello, hello everyone. Welcome to the session. So, I am SRINIVAS, Assistant Professor of Physics, NG College, Nalgonda. Today, in our session, we are going to talk about Unit 2, Chapter 2, Mechanics of Particles. Unit 2, Chapter 2, Mechanics of Particles. Under this chapter, today we are going to cover few topics, among them Newton's law of motion, and subtopics are Newton's first law of motion, what is force, Newton's second law of motion, Newton's third law of motion, and if time permits, we'll see linear momentum also. So before going to start Newton's laws, so first see, in our childhood days, we listen about a story. What is that? Newton's apple story. So during the summer days, Newton went to his grandparents' home. While playing, he sat under an apple tree. So when he sat under a tree, suddenly when an apple fall on his head, and immediately he responded that why the apple was coming towards the earth, why it is not going upwards from the earth. So we all know that immediately he told us that is due to the law of gravitation of force, gravitation of attractive force. So then after he proposed different laws, among them Newton laws and the fundamental laws. And now let us see first one, Newton's first law of motion. What is Newton's first law of motion? Let us say generally we everyday experience what we are going to talk about, all these laws. First, actually, what is the branch of mechanics? What is the branch of mechanics? See, mechanics is the study of motion of particles and bodies. Mechanics is the study of motion of particles and the bodies. It may be rest bodies, or it may be bodies are in motion. Okay. So we all discuss under the branch of mechanics. And now let us see our actual topic is Newton's first law of motion. Let us see the statement. It states that every body continues in the state of rest or of uniform motion in a straight line unless an external force acts on it to change that state. See there, every body continues in the state of rest or of uniform motion in a straight line unless an external force acts on it to change that state. For example, when we place an object on the table, it is in rest position unless we apply force to change that position. Otherwise, if a body is moving on the road, if there is no friction, it may be continue its motion. But due to the earth friction, it may be stopped somewhere. So this is all about Newton's first law. This law is also known as law of inertia. See that this law is also known as law of inertia. It is the inherent property of a particle. It is the inherent property of a particle to oppose the change of state. It is related to the mass of particle. Remember, this law is also known as law of inertia. It is the inherent property of a particle to oppose the change of state. It is related to mass of particle. If the particle mass is more, then the inertia of that particle is more. Very simple thing. Okay. Now, let us see a few examples under this first law. A person standing in a train will experience all these application examples regularly. A person standing in a train will get a jerk when the train suddenly moves or comes to rest. Sometimes it may occur that person falls in a direction opposite to the movement of train. This is due to the inertia of rest. It may be so happen while traveling in the bus also. When we are standing inside the bus, if the bus moves suddenly, it may be chance to fall. Right? So we all experience this thing. That is due to the inertia of rest. See here the different types of inertias are there. This is due to the inertia of rest because we are in rest position. When the train or bus suddenly moved, then we'll get jerk. Similarly, if a bus takes sudden turn while traveling, then passengers sitting or standing in the bus may bend away in opposite direction to the turn. This is due to the directional inertia. See that this one also we felt many times while traveling in the bus. Similarly, if a bus takes a sudden turn while traveling, then passengers sitting or standing in the bus may bend away in the opposite direction to the turn. This is due to the directional inertia. And one more example is there. Cyclist going with high speed. If cyclist going with a high speed, if suddenly applies the front brakes to stop it, then we may fall. This is due to the motional inertia. So many times we experienced this example also while practicing cycling, while during the practice of bike riding. We don't control ourselves. We suddenly, while traveling on the road, when we are in high speed, if suddenly anything come across before our vehicle, we suddenly press the front brake to stop the bike immediately. But what happened? So it may be slipped. It may be chance to fall down from the bike or cycle. This is due to the motional inertia. These examples all are related to first law of motion. Next, move on to the next thing is force. What is force? Many times we talk about force. Someone forced me to join here. Someone forced me to do these things. That is in general case. What is force? Generally, while talking, someone forced me. In what extent? How extent he forced me? By some words or some doings. Okay. No, but come to the subject point of view. What is force? It is an agent which accelerates a body. For example, I am sitting here, someone pushed me to move forward direction. What is that? What is that? What he is doing? He is applying some force on me to move some extent. That means he is giving some acceleration by applying force, right? For example, let us assume one ball is there on the table. So if you push the ball, it may move forward direction. So in this mode, what we are doing, we are supplying the force to get the acceleration of your body. So in this way, we can say that it is an agent, force is an agent which accelerates your body. Next point, force is an agency to change or trying to change the state of the system, right? Force is an agency to change or trying to change the state of the system. Next, second law of motion, Newton's second law of motion. Let us see what is Newton's second law of motion. I have given the picture in the PPT, see there carefully. Newton's second law states that the rate of change of momentum of a particle is equal to the net force acting on the particle and takes place in the direction of force. See there? Rate of change of momentum of a particle is equal to the net force acting on the particle and it takes place in the direction of force. See, rate of change of momentum. What is momentum? How can we explain momentum? It is represented by P, where P is equal to, momentum is nothing but product of mass and the velocity of the object, right? Momentum is nothing but mass and product of mass and the velocity of the object. If there is no mass, we can't say, we are unable to talk about the momentum. If there is no velocity, body is in rest position, then momentum is zero, right? Now the change in momentum with respect to time is called force, right? Where F can be written as F is equal to dP by dt. In the picture you observe there, a person is applying some force on the box. Now the box is moving the direction of force, right? Now let us move on to the product of mass m and its acceleration a is equal to the force acting on the body. We can also define the force is the product of mass and acceleration of the body. F is equal to ma. And the units of force are what? Newtons, kg meter per second square, dynes. You know that Newton is SI units and dynes are CGS units and kg m per second square are MKS units. We all know about this, right? Now we know that 1 Newton is equal to 10 to the power of 5 dynes. We all know very well this thing. And let us move on to the Newton's third law of motion. What is Newton's third law of motion? See that this law states that for every action there is an equal and opposite reaction presented, right? For every action there is an equal and opposite reaction presented. So if you observe the picture carefully, children applies the force on the wall, which is action. In turn, wall applied the same force on the children in opposite direction, which is reaction, right? See there. The law states that every action there is an equal and opposite reaction present. As shown in above picture, the children applies the force on the wall, which is action. In turn, wall applies the same force on the children in opposite direction, which is reaction. Right. Let us see a few examples. See there, a book placed on a table applies its weight or force on the table, which is action. In turn, table applies the same force on the book in opposite direction, which is a reaction. Next example is a revolving moon attracted by the earth, right? A revolving moon attracted by the earth, and at the same time the moon also attracts the earth with the same force, right? Revolving moon attracted by the earth, and at the same time the moon also attracts the earth with the same force. So that is also due to the Newton's third law, right? Next, third point, even in an atom, the Coulombic forces between the nucleus and electrons also constitute action and reaction pair. We know that electrons are revolving around the nucleus, electrons are negatively charged particles, and the nucleus is positively ion core. So there must be exist attractive forces, Coulomb attractive forces. But the electrons are not attracted by the nucleus. See there, electrons always revolving around the nucleus in its stable orbits. So what type of force acting on the electrons to balance the new Coulomb attractive force? Just imagine, right? And also one thing is there, the force acting between the two objects from the second point here is F is directly proportional to m1 m2 by r square. If we remove the proportionality constant, we will get universal gravitational constant capital G. F is equal to capital G m1 m2 by r square. For example, if we consider m1 is the mass of the moon and m2 is the mass of the earth, and where r is the distance between them, see there, we know that if we put the two magnets certain distance, let us assume one magnet is bigger than another one. So it is obvious that smaller one is attracted by the magnet and moves towards the bigger one. Similarly, Earth is, comparing to moon, Earth is bigger than the moon, right? But is there any possibility to attract the moon towards the Earth? Why it is not moving towards the earth? Just think about it. The attraction of earth is compared to moon more, but why moon doesn't move towards the earth? Just think about it, right? Next, fourth point, the motion of rocket is based on Newton's third law. We know that. We'll take large amount of fuel backside of the rocket. When the fuel burns rapidly and it releases some gases from outside the rocket, from the bottom of the rocket, and the rocket is moving forward direction. The faster the burning of fuel, the rocket moves faster forward direction. Okay. And the fifth point is, in a case of a swimmer, as the swimmer pushing the water in background direction, the water in turn pushes him in forward direction, right? In case of a swimmer, has the swimmer pushing the water in backward direction, the water in turn pushes him forward direction. So this one also the best example of the Newton's third law, right? So In the next class, we'll see linear momentum and its properties. Okay, so thank you very much.